All right, welcome back, ladies and gentlemen. So now let's get into the processes for our polar equations. And the first one I want to do is just kind of convert from rectangular points to polar because we're most familiar with rectangle points. Let's try to see how we can understand these in our polar form. So the first point is 4, 0. And I think majority of you can kind of realize that, well, I probably don't need to use the formulas here. I can probably figure, I can plot this point 1, 2, 3, 4. This one's rather easy. Now, we need to understand, though, when we're trying to convert into polar form, we want to write this into r comma theta, right? Where r represents how far we are away, which we could say we are 4 units away. And then what is the angle? And the angle, we're going to use degrees in this case, is just going to be 0 degrees. Now, if we wanted to go ahead and use the formulas here, right, you could say like 4 squared plus 0 squared equals r squared. And what you'd get is 16 equals r squared. So therefore, r equals 4. And then we could do the same thing with the tangent of theta, right? So you could say the tangent of theta is equal to 0. Oops, I'm sorry. 0 over 4. With therefore, the tangent of theta is equal to 0. And therefore, when you take the tangent inverse of 0, you would obviously just go ahead and get 0 degrees. So theta would equal 0 degrees. All right. So that's just kind of working through the math. However, what I'd recommend you do for each of these problems is to still plot them, even if you don't know like what they're, even if you don't know where the point is. I want you to go ahead and plot them on the coordinate grid because this is very important to understand where the point's going to be, because we want to make sure when we find our angle that we're plotting the correct point. So in this case, we have a negative 2 square root of 2 and a negative. So we know that a negative and a negative, that's going to be some point over here, right? Okay, now in this case, finding r squared is going to be a little bit more work. So what I'm going to do is I'm going to say, all right, well then negative square root of 2 quantity squared plus negative square root of 2 quantity squared equals r squared, right? Okay, well, the nice thing about this here is if you were to take the negative square root of 2 times negative square root of 2, that's going to be 2. And 2 times 2 is 4. So therefore, I'd have a 2 fourths plus, again, another 2 fourths equals r squared. Here, I can just go ahead and combine the numerators, right? So that's going to be a 4 over 4 equals a r squared. And then you take the square root. Obviously, r is going to equal 1. You say, oh, okay, yeah, that actually makes a little bit of sense because I recognize that point to be on the unit circle. But I want to show you the work, and kind of, maybe you might have noticed that before, but, you can always justify the work here, right? But that's the coordinate point here in the unit circle. Interesting. All right, so let's go and find the angle. Now, again, the nice thing about this is when you take the tangent of theta, like whenever I take the negative square root of 2 over 2 divided by negative square root of 2 over 2, that's equal to 1, right? I mean, you don't really need to do the work. Tangent of theta equals positive 1. But here's where things get important. Because if I was going to find the tangent inverse, right, I do tangent inverse of 1, guess what I'm going to get? I'm going to get a 45 degrees. Now, that's an issue. And actually, this one I just wanted to show you just in case you kind of forgot. How did I get 0? Remember, that's theta equals tangent inverse of 0. Okay? And theta equals 0 degrees. Well, that's a problem because, guys, where's 45 degrees? 45 degrees is over here. My angle is over there, right? So remember, the reason why this is happening is because tangent inverse is restricted between the first and the fourth quadrant. So it's only going to give us this angle. So we just got to remember that this angle is going to be the same, right? This basically what it's giving you is this reference angle here. So therefore, if I know this is going to be 180 plus 45 degrees. So I can basically say theta equals 180 degrees plus 45 degrees. And hopefully you maybe just recognize that to be, 225 degrees. Okay, so therefore my polar coordinate here is going to have 1, right? That's the distance away, the polar axis. That's 1, the radius, and then 225 degrees. All right. Now let's go and do another one. Here, 1, 7. So let's go and find this. Let's find out the quadrant where this one's at. There we go. Okay, so 1, -7. All right. So we're dealing with somewhere like right around there, right? Well, actually, let's figure that out. So there's our coordinate point. And I don't know the distance here, r. Let's say that's going to be my distance r, right? So to find this, again, we do r squared equals 1 squared plus -7 squared. So r squared is going to equal 50. So therefore r equals the square root of 50. Now we can go ahead and simplify this. Let's see, you could do 25. R equals the square root of 25 times 2. Right? So r is equal to 5 square root of 2. Okay, and then the next one is going to be finding the angle. Now again, this one's nice because this is in the fourth quadrant. So we can go ahead and use the negative angle. In this case, I'm going to use, you could use the negative or the positive angle. I'll give you both examples so you can kind of see it doesn't really matter which one you use. But your calculator though, when you do this, you're going to have the tangent of theta is going to equal my y coordinate negative 7 over 1. So therefore I have theta equals the tangent inverse here of a negative 7, right? So when I go ahead and do this on my calculator, and when you type this in, I'm going to get my degree. So tangent inverse of negative 7. That's going to give me theta equals a negative 81. I'm going to round this to the nearest tenth. 81 point, or nearest, let's do the nearest hundredth. 81.87, okay, degrees. Well, now that's one angle, right? So you could write this as a radius of 5 square root of 2, negative 81.87. That's fine, right? That's from there to there is negative 81.8. Is it 87? Yeah, 87. Well, what if I want to do this angle? Would it still be the same? Yes, because remember, those are coterminal angles, right? So all I need to do is add that to 360 and say, oh, well, if I did, theta, I could also do 360 minus an 81.87, and that would give me a 278.13, right? Degrees. So therefore, you could also do it as 5 square root of 2, comma, 278.13 degrees. And I don't know what your, professor or teacher might want. They might want only positive. They might want the smallest angle, whatever may be the case. But there you can see there's multiple representations, and that's going to become important. We're going to expand upon this a little bit later. All right, and now let's go and do the last example here. So in this example, again, let's go ahead and plot it. Okay, so this one this is in negative positive, so that's going to be somewhere here in the second quadrant. That's an issue, right? Because it's not going to fall within here and here. So therefore, what we're going to do here is let's go ahead and do them. So in this case, we have r squared equals a negative 2 squared plus a 2 square root of 3 squared. Okay, so r squared equals 4 plus, now let's do this. 2 times 2 is 4. Square root of 3 times square root of 3 is 3. So 2 times 3, or 4 times 3 is going to be 12. So r squared is going to equal 16. Well, that's good. R equals 4. I like that. Now let's go and see if we can figure out the angle. So we could say, all right, well, let's see, tangent of theta equals a 2 square root of 3 divided by a negative 2. All right, so the 2's will divide out. So I have a tangent of theta is equal to, tangent of theta is equal to, this one's kind of weird. This is going to be a negative square root of 3. Okay, now you might need to remember on the unit circle, or obviously, hopefully you remember on the unit circle. You could obviously go ahead and use the tangent inverse. If you are looking into the unit circle, then therefore you get theta equals, let's see, that's going to be the y over the x. So therefore that is going to be a negative 60 degrees. Okay. Now, I'm just going to do tangent inverse of, I just want to make sure I did my work right, because I don't want to, not sure if I remember this exactly. Yeah, I got that right. Okay, perfect. Now, this is kind of interesting because there's a couple different ways we can actually do this. Because some people might look at this and say, all right, well, my radius here is equal to, 4, and then I have this again, negative 60 degrees. So again, what's happening here is what it's doing is it's giving us this angle down here. Well, I don't want this angle, right? What I want is, I want the angle over here. So what's nice about this is we know the distance is 4, right? So that's going to be my negative 60 degrees. That means I know this angle, the reference angle here, we can just call it like theta prime is equal to 60 degrees. So therefore, to find my angle, I can just do 180 minus 60 degrees, right? Which is going to give me 120 degrees. So my polar coordinate here is going to be 4, comma, 120 degrees. Okay, so that's how we convert to our rectangular into our polar points. And I think it's kind of important to understand what we are looking at here when we are trying to, it's important to kind of look at when we're looking at our rectangular points that we understand the quadrant. So therefore we can understand the angle as well as the distance away from our origin or our pole. All right, so now let's just go actually and practice sketching our polar points. So now hopefully you have an understanding of the angles. I'm going back to radian mode to kind of remind you of how to do radians. We could easily just swap these out for, degrees. And now what we're going to do is we're going to plot them on the polar graph. So when the first number, again, remember all of these are in the form of r comma theta. All right, now, I didn't do the best of job here for my side, so I'm just going to create some extra poles here so you guys can kind of see what these represent. Okay, so let's just create some new poles. All right, and these new poles are going to represent my pi over 4. So this is going to be pi over 6. This will be pi over 4. This is going to represent a pi over 3. And this will be representing my pi halves. All right. Okay. So the first one is going to be r3 comma pi over 6. So obviously what 3 represents is ring 3. So 1, 2, 3, right? And then pi over 6. And you can see that's going to intersect here, pi over 6, and then my distance r, which is like 3 rings away. So did I label these? No, I did not. So let's do this A, B, C, D, E, F. Therefore, it's a little bit easier to kind of remember which point was which. All right, then we're going to do 5, negative 3 pi over 4. So in this case, we're going to do 5. All right, so ring 5, 1, 2, 3, 4, 5, and then negative 3 pi over 4. Well, again, this is pi. If this is pi over 4 in the negative direction, right? Remember, negative direction is down here. Counterclockwise is positive. So this would be negative 1/4, negative 2/4, negative 3/4, right? And then we're at ring 5. So 1, 2, 3, 4, 5. B. There you go. All right, now the next one is where things get confusing. So I have a negative 4 pi. Now, this is confusing because how is the distance away going to be negative? Well, in this, we're going to have to kind of understand a little bit as far as our conversions or understanding our coordinate points for these. So remember that all of our points here from negative 4, these can be rewritten here, like as we are looking into converting our points, right, between the x and the y. We could go ahead and convert these points here. It's important for you to understand that I can represent this as this is my r, right? And this is my r and this is my theta. So if I want to go ahead and represent these as a coordinate point here, I could say, all right, well then x equals, right, negative 4, come on, negative 4 times the cosine of theta. And y equals negative 4 times the sine of theta. Okay, so what is our theta? That theta is going to be pi. So we have negative 4 times the cosine of pi, and y equals negative 4 times the sine of pi. Oops. So let's write in pi. Okay. So what this negative is doing, and this is actually reflecting about our origin. So what I want you to understand in this case is when you take a look at this pi, like let's just graph what 4 pi is. Okay, so 4 pi would be over here. So 1, 2, 3, 4, right? So that's going to be C prime. Now, what happens when I have the negative? Well, what the negative is going to do, it's going to reflect about the x and the y axis. You're reflecting basically about this origin. So therefore, what you're going to have is really 1, 2, 3, 4. We're just going to go in this opposite direction. Okay, so that's going to be our point C. Now, you might say, well, how am I getting this, right? Because obviously, if you did 4 and pi, then you would cosine of pi. So let's do the math here. So if this was cosine of pi is equal to 1, right? And sine of pi is equal to 0. So what I want you to see is all we're getting here is a negative 4, and y is equal to 0. So if this was a positive 4, of course you'd have 4, right? It'd be going 4 units to right. But since my 4 is negative, what that's doing is that's going to the left. So what this negative does is just reflects it about our origin. So again, this is a different point. We'll work on another negative here over here, but all that negative is doing is reflecting about the x and the y. So therefore, that's going to be your point C. So typically what I like to tell students to do is to plot the point in the positive direction and then reflect it about the origin. Let's go and take a look at another example. All right, so in this case, let's go ahead and plot 2, comma, a negative 4 pi over 3. Now again, the negative, don't really worry about that, okay? So 2, negative 4 pi over 3 is, if you were to go ahead and plot this, that would be ring 2, and we're going to do negative 4 pi over 3. So these are your pi over 3. So let's see, 1/3, 2/3, 3/3, and then that would be 4/3. So what is it, 2? Okay, so there is going to be my 4 pi over 3. So that's going to be my d prime. All right, so I'm going to say this is d prime. Did I label that other one? I did not. Let's call this c prime. Okay. All right, so now if I was to reflect this about the origin, all I'd simply do is reflect it about my x and then reflect about my y. So there's going to be my point D. Now let's confirm, right? So if I do my math correctly, then what that means is I'm going to have a x and the y coordinate that are in the fourth quadrant. That means the x would be positive and the y would be negative. So let's go and check it out. Let's go and see if that works. So remember, all these polar points can be rewritten as negative 2, the cosine of negative 4 pi over 3, comma, negative 2 sine of negative 4 pi over 3, right? That's how our coordinate points can be written. X cosine of theta, y sine of theta. Okay, so let's just go and do the negative 4 pi over 3. So cosine negative 4 pi over 3, that is going to be a, let's see, that's going to be a negative, let me see, that's negative 1/2. Right? If you were to do that, that's in the second quadrant, right? Wouldn't you guys agree? Negative 4 pi over 3, that's in the second quadrant. That means cosine is negative. The sine of 4 pi over 3 is going to be a square root of 3 over 3. So this would be a negative 2 times a square root of 3 over 2, right? Because second quadrant would make this angle positive. However, we're multiplying it by negative. And not only are we multiplying the x by the negative, we're multiplying the x and the y by negative. So what's happening is you're taking this coordinate point, this negative 4 pi over 3, right? And you're multiplying it by negative. Well, when you multiply the x coordinate by negative, that reflects it about the y-axis. And we reflect the y coordinate by negative, that reflects it about the x-axis. And what you get is this positive 1, comma negative square root of 3, which is exactly what this point looks like at D. All right. All right, so now let's get back to some easy ones. In this one, we have 1 comma pi. So that's nice. So we're going to go to 1, and then we're going to be at pi, which is pi is over here. Oops, so there we go. So that's E. I was getting so happy with the reflecting, right? All right, and this last one, again, I would just do f prime. So that's going to be a 6 comma a 3 pi over 2. So let's go 3 pi over 2 and coordinate point. So that's going to be over here. So 1, 2, 3, 4, 5, 6. That's f. And now, again, I'm reflecting the negative is not really going to change, but I reflect this, it's just going to be up. So that's his f prime. So then 1, 2, 3, 4, 5, 6. And that's going to be your point F. Okay, so that's how that kind of works. And from there, now let's go and take a look at actually just converting the polar points, which we were looking for, which we kind of like investigated of why this, the x and the y coordinates, if we're given our sine of theta and our cosine of theta, we can just find the x coordinates, right? All we simply need to do is say, all right, this is x. This is, if I want to find xy, then I can just rewrite this as r cosine of theta times r sine of theta. And that's going to give me my x comma my y. So all I'm going to do is just go and plug in this information now. So 1 is kind of nice, right? I mean, I'll put it in there so we know it's there. But I mean, as long as we know our points, we should be pretty good. So the 1 does not really change anything, but why am I writing a sine before the cosine? So therefore, this is going to be a cosine, and this will be a sine of pi over 3. Okay. So now I just got to make sure we know our points. Pi over 3, that's going to be a 1/2. Sine of pi over 3, that's going to be a square root of 3 over 2. All right. Here we have the 4. And let's see here. Okay. If we were to, okay, so let's go ahead and do this one just a little bit low. So I'll do a 4 times a sine of 7. Why am I doing sine first? So this would be a cosine of 7 pi over 6, and then times a 4 times a sine of 7 pi over 6. Okay, so cosine of 7 pi over 6, let's go ahead and plot that real quick. 7 pi over 6 is right there. Okay, so hopefully you know here that's going to be a 4 times the square root of 3 over 2, comma, a 4 times, and then sine would be 1/2. Okay, so this is going to be giving me a 2 square root of 3, and this would give me a 2. And there we go. All right, now the next one. This is, again, where everything is going to now start to come together. Like, why does this work? Why does this negative? Like, let's just go ahead and plot where this point should be. So typically, let's just call this P. So P prime, let's just do graph 5, right? So, 1, 2, 3, 4, 5. All right, so negative 3 pi over 4, which is right there, and then row 5, right? So there is P prime, right? P prime is the positive version. So let's just put that there. Oops. So let's write P prime is going to be 5 comma negative 3 pi over 4. Now, if we do this correctly, my coordinate point that I get, my x and y coordinate, better be in the first quadrant, because if you reflect about the origin, it's going to be in the first quadrant. So let's see if this works. So again, all I'm going to do is just plug in my number. So I have a negative 5 times a, oops, we don't really need that, negative 5 cosine of a negative 3 pi over 4, comma, negative 5 times a sine of negative 3 pi over 4. Okay, so negative 3 pi over 4, let's go and see here. That's going to be the coordinate point. That's going to be a negative. Everything's negative, right? So we'd have a negative 5 times, let's see, that's going to be a square root of 2 over 2, comma, a negative 5 times a negative square root of 2 over 2. And what do you know? Is the point down here, right? Is it down here? No, right? And even though the negative 3 pi over 4 takes you down here, that's for the positive. What's happening when you multiply this negative, that's reflecting it up to this first quadrant. So what this gives us here is a positive 5 square root of 2 over 2, positive 5 square root of 2 over 2. Whew. All right, here's another negative. Again, this one is going to be relatively easy if we think about what the point is. So we have pi halves, and if we reflected about the origin, that's going to take us down to the y coordinate, or the negative y version. But either way, let's just go ahead and plug it in. Like, it's simple enough. So negative 2 times the cosine of pi halves, and then negative 2 times the sine of pi halves. Okay. And I guess I could put them in parentheses. So cosine of pi halves, if you were to kind of graph where cosine of pi halves is, right, that's going to be up there. So that's going to be what? 0, comma 1. So this is negative 2 times 0, comma, negative 2 times 1. So therefore, this is 0, comma, negative 2. Which makes sense, right? Because if you were to plot this point, you're not going to go negative 2, this is that point, and then you're going to go down 2 right there. So that's going to be your negative 2 pi halves is going to be, oops, down here, not up there. So a lot of people want to do this is the point 2 comma pi halves. So the negative just reflects it, okay? So that's the important thing to understand. This is P prime, that is P. So that's going to be P, that's P prime. Just very important to kind of know that distinction. All right, so now let's go and take a look at 3 different representations that we can have for these points. Because one thing that we've kind of looked at when we looked at the graph is, if you have a coordinate point over here, like let's say we have this coordinate point. Well, one thing we could do is we could find the positive angle, we could find the negative angle, and we could find the angle that is in the negative direction, right? Now the interval that I'm going to do is between 0 and 2 pi. And we're just going to go ahead and find 3 different representations. But I want you to understand those are kind of like some 3 options we're going to look at. So the easiest one to do is to go ahead and find an angle that's going to be coterminal with your 2 pi over 3. Now, if we want to stay between 0 and 2 pi, I'm not going to want to add 2 pi to this, 2 pi over 3. But what I'm going to do is want to subtract it. So I think for this first problem, and we have the space, why don't we just go ahead and graph this? And, we have 2. Okay, so 2 pi over 3, that's going to be over here, right? So there is my point A. Okay, so why don't we just find the coterminal angle, right? So if here is 2 pi over 3, why don't we figure out what this angle is? Well, hopefully that's going to be, so let's go ahead and find a coterminal angle. So let's say 2 pi, actually, minus a 2 pi over 3. Well, that's the same thing as if we want to write this, we could say 6 pi over 3 minus 2 pi over 3. And that's going to equal a 4 pi over 3. So I could say the same coordinate points, but I could say 2 comma 4 pi over 3. Right? That works. What about this angle? What would this angle be? Well, in this angle, it's just going to be the negative version, right? But what we have to do is we have to figure out what that angle is. So we have to figure out what this angle is and then reflect it. So what we're going to want to do here is find this reference angle, right? If this is 2 pi over 3, then we know theta prime is equal to pi over 3. That's important because what does that tell us about this? Well, that means that is theta prime, right? So we could say, to go from here to here, I could do theta equals a negative pi over 3. So therefore, my third point I could use would be a negative 2 comma negative pi over 3. Right? Because that's going to take you to this point, and then when you multiply by negative 2, that is going to reflect you over to here. All right, let's go ahead and try that again. Do another one. So in this one, again, we can find, let's go ahead and graph it. So 1, 2, 3, 4, just to be as consistent as I can. So 5, we're going to do negative 5 pi over 6, which is going to be right there. Okay. And negative 5 pi over 6. So we got this angle. Well, let's go and figure out what that angle is, right? Now, again, you could do if we know that's negative 5 pi over 6, what would that angle be? So hopefully you kind of recognize oh, well, that's just going to be a 7 pi over 6, right? Now let's go and figure out what this angle will be. And again, we need to understand what the reference angle is. This reference angle is going to be pi over 6. That means this angle is going to be pi over 6. So if you're going to use the negative version, right, reflecting about the origin, you're just going to use a negative 5 comma a pi over 6. Okay. And then last example here. Now this one we could go ahead and find, so this one we're going to want to actually graph this one. So this one's kind of a look at. So we have 1, 2, 3. Let's do that in circle again. Horrible circle, but that's okay. 4. All right, so let's go ahead and find 7 pi over 4. So 7 pi over 4 is going to be right over here. It's on ring 4. But remember, let's actually graph this. So let's call this point P. Let's go ahead and find P prime. So P comma 7 pi over 4, that's going to be P prime. All right, so if I did 7 pi over 4, that would be right there. That's P prime. But again, remember, if you're reflecting about the origin, it's going to be over here, right? So there you go. That is going to be my point P. So that's P prime. That's P. Now, a couple things we could do. I did 7 pi over 4. Couldn't I also do, if I did negative 7 pi over 4, how far is that? Right? The reason why I got that negative 7 pi over 4 is because I did this angle. Right? But couldn't I just do this angle too? I could do the negative version of that. And yeah, you could. So I could do negative 4 comma negative pi over 4. That's kind of nice. And then if I want to do the positive version of this, again, my reference angle here is pi over 4. So therefore, if that's a reference angle pi over 4, then I could also do the positive version of 4 comma 3 pi over 4. All right. And then also you could do the coterminal angle if you wanted to do that as well, to get 4 points technically. But we'll just keep it at that. All right, so now we get into the fun stuff. So now what we're going to do is we're going to work on converting our rectangular and polar equations. So we're going to start with our rectangular equations. And it's fairly basic when we're looking at rectangular equations. What we're going to want to do is whenever we see an x and a y, we're going to replace them with r cosine of theta, r sine of theta. And whenever we have an x squared and a y squared, so x squared plus y squared, you're going to want to replace that with a r squared. And then last but not least, if you have a y over x, you can also replace that with a tangent of theta. Okay, and again, remember this is coming from our notes section. And as well as this makes sense for how we converted our coordinate points as well. So remember when we had x and y, if we want to convert them to our r theta, we use these two equations. So in this case, we see the x squared and the y squared. So we can say r squared is equal to 16. Okay, and if we want to solve this, sometimes it's easier to solve, sometimes it's not. But in this case, you could just say, you could take the square root of both sides. You can say r is going to equal my positive 4. Okay. Yeah, r is going to equal a positive 4. And we don't need to do a plus or minus because, again, r represents that distance, right? It's a positive distance away. All right, in this one, we have y. So we can just replace this as a r sine of theta is equal to a negative 5. Okay. And then you could go ahead and a couple different ways, we can rewrite this. You could divide by sine of theta on both sides. Sometimes you'll see these problems written in different ways. So it'd be negative 5 over sine of theta. Sometimes we'll rewrite sine as cosecant. So you could rewrite this as 9 5 cosecant of theta. So just multiple different ways we can kind of rewrite these. Here we're going to have an x and a y. So I'm going to rewrite this as 3 times r cosine of theta plus 2 times r sine of theta is equal to 1. Okay. Now here again, if we want to solve for r, we can't combine these. They're not like terms, but we can factor out the r. So by factoring out the r, I'm left with a 3 cosine of theta plus a 2 sine of theta is equal to 1. And then you can just divide by that on both sides. So therefore r equals 1 over 3 cosine of theta plus a 2 sine of theta. And voila. All right, on the next one. Now this one's kind of interesting because we don't really have anything just for x squared. So one thing we might want to do is maybe just rewrite this here as say, well, I could also rewrite this as a negative 4 and then quantity x, quantity squared. So if you do it like that, you could say, well, then that is going to be r sine of theta. And this is going to be a negative 4 r cosine of theta squared. Well, now I can square both of those terms. So I get an r sine of theta equals negative 4. And here I can get an r squared cosine squared of theta. Now, the solving for the r is not going to be as simple in this case, but you can simplify r or factor out the r here. Factor out a minus r sine of theta. And when you do that, you get 0 equals a negative 4r squared minus a r sine of theta. Okay, now in this case, you could factor out the r. And by factoring out the r, you're going to be left with a 4 or a negative 4r minus a sine of theta. Which, if you use the zero product property, r equals 0, and a negative 4r minus sine of theta equals 0. This one doesn't really make too much sense, right? R equals 0, that's literally a dot at the origin. So therefore, my only answer here is going to be this one. So I can rewrite this as negative 4 equals a sine of theta, and then divide by negative 4 on both sides. So r would equal a negative 1/4 sine of theta. Okay, now again, once you've kind of converted it, technically it's a polar equation, but you can see this is going to be this extraneous kind of equation here. So this is really going to be our only equation that we'll have. All right, so in this example, we have an x and we have y, so we could write these as r cosine of theta, r sine of theta. But I think if I was going to expand these, that's going to kind of make things a little bit more difficult. So what I'm going to do is let's go ahead and expand them with the x's and the y's, and then go ahead and convert them and see what that does. So if I was to convert these, I get x squared minus a 2x plus 1 plus a y squared plus 2y plus 1 equals 2. Okay, well, now let's kind of group the x's and the y's together. So x squared plus y squared minus 2x plus 2y plus 2 equals 2. All All right, well, now I recognize x squared plus y squared. That's going to be an r squared, right? X, so we'll write that as r cosine of theta. A y, we'll write that as a sine of theta, so an r sine of theta. And then you could subtract these to equal 0. So here you have multiple r and an r squared, so you can't combine anything. The only thing else you can really do is factor them out. And since it's equal to 0, we're going to x minus a 2 cosine of theta plus a 2 sine of theta equals 0. Again, now that you have this product equal to 0, you can again apply the 0 product property. But again, we don't need to worry here about this because r cannot equal 0. That's not going to be an equation that's going to represent this. So therefore, we'll be left with a r minus 2 cosine of theta plus a 2 sine of theta equals 0, right? And therefore, I'd have r equals, let's see, that's going to be a positive 2 cosine of theta minus a 2 sine of theta. And voila. All right, into our last example here. Again, same idea kind of here. We could convert these, but again, if I have a y squared, I'm going to want an x squared, right? I mean, that's typically what we want to look for. So let's go and expand this out. So if I have a y squared, expand this out, that's going to be an x squared plus 4x plus 4 equals 9. Then let's see, x squared plus y squared equals r squared. And then you could subtract a 4, subtract a 4. Let's see, that's going to be a plus a 4x equals 5. We can rewrite x as r cosine of theta. So r squared plus a 4 times r cosine of theta equals 5, right? Now, r cosine of theta, remember, is equal to, we already have this exactly where we want it. Now here, again, there's really not much that we can simply do here. We can just, we can't factor out you could factor out the r, but again, that's not equal to 0, so it's not really going to simplify anything. So we're just going to leave this answer as a 4r cosine of theta is equal to 5. There's really not much we can do now to further simplify this. All right, so let's go and take a look at now going backwards. So now what we're going to do is we're going to convert from polar equations to our rectangular equations. So kind of the same idea. Our kind of goal though now is to kind of create either a r squared or create a r cosine theta, r sine of theta. So when we have an r sine of cosine theta, r sine of theta, we can use these as x and y's. When we have an r squared, we can convert them to an x squared plus a y squared. Same kind of thing. If we have a tangent of theta, we can rewrite them as y over x. So our goal here is to eliminate the r and write things in terms of x's and y's. All right, so the first one here might not be as obvious. So again, cosecant, we haven't talked about cosecant. Let's rewrite this in terms of sine. Well, if you write this in terms of sine, you say, well, I can get sine off the denominator by multiplying a sine on both sides. And when you do that, you get an r sine of theta is equal to -1. And you say, hey, r sine of theta, that's just equal to y. And voila. R equals, now in this one, there's not really much I can do. You don't really want to multiply by the cosine, because then if you multiply cosine on both sides or a sine on both sides, like which one do you pick, right? So what we're going to want to do in this case is, and we don't want to multiply by an r on both sides because then we'd have an r over here we'd have to get rid of. So in this case, what we're simply going to want to do is square both sides. By squaring both sides, I get an r squared is equal to 4. So therefore, it's an x squared plus y squared equals 4. And that is your rectangular equation, which you can represent, hopefully you recognize represents a, from our parametric equation, that represents a circle. In this example, I can divide by 3. If I can solve this for tangent of theta, -3 divided by 6 equals -2. Well, again, what is tangent? Well, remember, tangent is y over x equals -2, right? So if I just want to solve, you can see this is the equation of a line. So y equals a -2x. And there you go. All right, next example here, we have r equals 6 cosine of theta. So in this course, again, to simplify this, we got to get r times the cosine of theta. So what we're going to want to do in this case is, we're going to want to multiply by an r on both sides. So we have r squared equals 6r cosine of theta. Now again, what is r squared? Well, that's going to be an x squared plus y squared. And then over here, we'd have a 6r. I'm sorry. Yeah, 6r. That'd be r cosine of theta is going to be a 6x. Now we'll just leave it at that. We're going to practice our next section. We will practice go ahead and completing the square for us, so we can recognize how this how this equation is going to come about. But for right now, we'll just kind of leave it in this form over here. Okay, so in this example, the first thing I recognize is I want to get this off the denominator. So I'm going to multiply by 2 minus 4 sine of theta on both sides. So let's just get that off the denominator. All right, then, so I have r times a 2 minus 4 sine of theta is equal to 9, right? Those divide out. Okay, cool. Now we can go ahead and apply a little distributive property because I know r times sine of theta, that's going to give me what I want there. That's going to give me a, oops, not in that. That's going to give me a negative 4y is equal to 9. But I still have this r. So that's a little pesky r. So I don't want to multiply by r on both sides. I don't want to multiply by cosine times everything. Let's go and get this 4y to the other side and say, what can I do now if I have a 4y plus 9? Well, kind of going back to what we did over here, you could just square both sides, right? So if we square both sides now what that's going to give us is a 4r squared. And then this we could expand out to, let's say, a 16y squared. 4y times 9 is going to be a 36y. This is a binomial squared, so times 2, which would be a 72y plus 81. And then we have this is going to be a r squared is x squared times y squared, right? So we could do x squared plus y squared. So that'd be a 16y plus 72y plus 81. Then just go ahead and apply the little distributive property. 4x squared plus 4y squared equals a 16y plus 72y plus 81. And now we can simply, we can just leave it in this format. You could also, set it all equal to 0 if you wanted to. But I'm just going to leave it in this form, kind of like I did over there. All right, the next example here is, again, kind of the same thing. We, kind of like how we obtained an r, where was it? Over here, we're going to do the same thing. We just have a cosine and a sine here, right? So, but I realized that if I multiply everything times r, that's going to give me an r squared equals 2r cosine of theta plus a 2r sine of theta. Well, r squared, again, is x squared plus y squared. R cosine of theta is going to be a 2x. R sine of theta is going to give me a 2y. And that one's a lot easier than the other one, but hopefully you kind of have a better idea now of how to convert the equations. And that, ladies and gentlemen, is it for our lesson on the polar equations and everything that you're going to need to know. Now it's time for you to go and check your understanding in the quiz, and I look forward to seeing you in the next section. Cheers.